Okay, if you can't come to class or you need a reminder, here is the lecture for soil and soil organic matter. First off, what is soil? It's the dirt. It's the stuff that you get on your hands. It's soil when you're planting into it. It's dirt if it's on your hands. It's a combination of a lot of different things. Minerals, which we tend to call sand, silt, and clay. Organic material, which is usually somewhere between 1 and 6% typically. We can add some to make more. Notice that water and air make up the vast majority of it. The amount of air greatly depends upon the amount of water, and then all the rest are living organisms, things that you can see like worms, and things that you can't see like bacteria. Greenhouse growers tend to use soilless media rather than soil, and that is usually because they can control things a little bit better. Field soils tend to be compacted, they have low porosity, they may have low water holding capacity, and they have low fertility, and they have varying fertility. So when greenhouses are usually mixing their own medias, and they're not usually using a soil. Most of these soilless mixes are combinations of different types of organic material, various barks, peat moss, sphagnum moss, compost. You might see pumice, vermiculite, various levels of fertilizers being added, pesticides or fungicides being added, things like that, so that the growers can control exactly the components of the mixture that they want. There are some advantages and disadvantages both to soil and soilless. Soils are readily available. They tend to be very inexpensive. Soilless, you can meet the special needs of your plants. So if you're growing orchids, you can have a very, very well-drained soil. If you're growing perennials, you can have more nutrient holding capacity. You can make the drainage what you want. They also all have disadvantages. Soil tends to have less porosity. It tends to be more dense. Tends to have varying fertility levels. Soilless medias are very not cost effective. You need to add fertilizers to them. You probably need to add some irrigation for that. So there are pros and cons for both. Lots of times, though, you're not really given a choice. If you are a corn soybean farmer, you're not really choosing to use a soilless mix. You're going to use what you have on your land. All right, so the three basic components of a soil, the mineral components, are sand, silt, and clay, and that's based on size. And to give you an example, if sand which is the largest, if a sand grain was the size of an elephant, now you know how big an elephant is, then a clay particle would be the size of a period on a piece of paper. That's how different they are in size. So having sand in your soil can really improve your drainage and your water flow, but clay has lots of nutrient holding capacities. So what you see here pictured in the jar is something that we're actually going to do next week in lab, and that is look at the different soil textures and the different types of sand, silt, and clay in a couple of different soils. You will find these triangles in any soil textbook and all over the internet. Basically, all you're going to do is look at the amount of soil that you have, or the amount of the different minerals that you have in that jar, and you're going to roughly guesstimate how much sand you have in there, how much silt you have in there, and how much clay. So if you're looking at, you have maybe 20% clay, you can kind of go over and go, oh, I've got about 40% sand, and so that would leave me with about 60% silt, and you've got a loam soil, which is actually what everybody wants. Every soil has properties to it that are both good and bad. We always mumble and grumble about Ohio clay soils because they're poor for so many of these different things. But the reality is they hold water very well. They buffer temperatures very well. They actually have really high nutrient holding capacity as well because of the volume of clay. The two videos here, I'll link them on Carmen separately so that you can go watch them. One is the science of soil health, and the other one is how plants interact with the soil. They're both about 3 to 5 minutes long. The organic matter is a big component of the soil, and it's one of the things that we're always concerned about. It's basically dying and dead plants things that are decomposing. It may be, we think of, ooh, dead animals, gross, yuck. But if you look at the animals as the microorganisms, bacteria have a very short lifespan. So what we're talking about with dead animals is probably more likely dead and decomposing bacteria and other microorganisms in the soil. Gardeners will always talk about humus, not hummus, which is the stuff that you eat. Humus is basically a type of organic material that really is not going to break down a whole lot more. It's kind of amorphous in texture and in appearance. Most of the time you're talking about 1 to 2%, but because it's really not breaking down and the particles are fairly large, it can really alter the chemical properties in terms of water movement, in terms of cation exchange capacity, which is the movement of nutrients, different ions and cations, on and off the various particles in the soil, and that is how plants get their nutrients. That's as sciencey as we're going to get, so you don't have to worry. This is not a soils class. You're going to get classes for that. So why do we want to add organic material, OM, if possible? Right? It affects critical functions. It can be manipulated. Even farmers are adding organic material when they're adding the manure to their fields. Greenhouse mixes are basically different types of organic material. Landscapes and gardens can add organic material to improve drainage, to improve water holding capacity, to improve aeration, to add some nutrients to the soil. So it does a lot of different things for our soils. All of these things are good things. If we take a look at this, adding the organic material takes carbon dioxide out of the air because that organic material stores carbon dioxide. So it can really do a lot of good things. Is there any bad news? Yeah, from a grower perspective, it does dry out really, really easily. And once it's dried, it's very difficult to get wet again. So if you're using it in a landscape setting, you want to put your organic material on and then add your mulch on top of that. That helps prevent it drying out. For greenhouse growers, once it's mixed in, you just keep it fairly moist. Your irrigation will keep it moist and you don't have to worry about that. Acidifying soils in Ohio is not a problem because our soils tend to be neutral to alkaline in terms of their pH, so acidifying soils is not a problem for us. If you live in places where acidic soils are a problem, then you want to look at the type of organic matter that you're adding. Most of our crop management practices, if you look at this from an outside perspective, we see a lot of reduced till and no-till nowadays. We see a lot of contour plowing, a lot of use of cover crops, spreading of manure, high root mass crops. We're already doing those sorts of things because we've recognized the value in protecting the soil. From an ornamental perspective, especially for landscapes, turf areas, locally source your organic material if possible. In rural areas, you might be able to go to a farmer and get some of their compost pile. Incorporate that into your soils. Don't cut your plants in the fall, doing fall cleanup. Cut them in the spring. Again, that leaves that residue on the soil. These are a couple of websites. Again, the USDA has a lot of resources for farmers, for growers of all types, about how to save the soil, because ultimately that is something that we need to do. And again, the second one there, what happens when you till, is a little video comparing soil characteristics from till and no-till. And I'll link those in Carmen. I'll let you guys watch those on your own. As always, if you got any questions, don't hesitate to get in touch.